For our first day in 0314, we're going to review over some concepts that we're going to see throughout the course. The first thing I want to review is exponents. An exponent is a little tiny number that's at the upper right of something that we call the base. So in this particular example, we have 3 to the power of 4. 3 is what we would call the base, and the exponent is the 4. That's that small number in the upper right. So the question is, what is that small number in the upper right called the exponent? What is that telling us to do? So what the exponent is telling us to do is to write the base that number of times. So in this case, my base is 3. I'm going to write that base of 3 4 times. So the exponent tells me how many times to write the base and how many times I am multiplying that base times itself. So what is 3 times 3 times 3? Okay, so 3 times 3 gives me 9. 3 times 3 gives me 9. 9 times 9 gives me a final overall answer of 81. In this class, you are also encouraged to use a calculator. So I'm going to recommend an online calculator called Desmos, desmos.com. So if you go to that website, you're going to click on Graphing Calculator. And then at the bottom left, you're going to see a keypad. So if you click on the keypad, we're going to do 3 times 3 times 3 times 3. And that gives us 81. So you're welcome to use Desmos to do the calculations. Okay, so let's look at our next example. We have negative 2 to the power of 3. Now this time, what is the base? The base is always the number that's directly in front of the exponent. And you can recognize that exponent because it's always a tiny number in the upper right. So it's always really tiny. The number that's directly in front of that exponent is what we would call the base. If there are parentheses directly in front of that exponent, then the base will be everything that's inside of the parentheses. So in this case, the base is negative 2. The exponent is telling me to write that base times itself 3 times. So we're going to write that base 3 times multiplied times itself. So that's what an exponent is telling me to do. How many times to multiply the number in front of it times itself. So negative 2 times negative 2 times negative 2. Let's review our rules for signs. If I multiply a negative times a negative, what do I get? Well, we get a positive answer. What if I multiply a positive times a positive? We also get a positive answer. All right, what do we get when we do a negative number times a positive number? When we do that multiplication, we get a negative. So in multiplication, if the numbers that we're multiplying together have opposite signs, then the answer will have a negative number. So what if I do a positive times a negative? Same thing. They have opposite signs, so we would get a negative result. So if I multiply negative 2 times negative 2 times negative 2, the first thing I might do is negative 2 times negative 2. A negative times a negative would give me a positive. And then I have to bring down the other multiplication of negative 2. Positive 4 times a negative 2, that's going to give us a negative answer, which is a negative 8. All right, we can also do this calculation in Desmos. So let's bring that up. All right, so I'm going to do this 2 ways. We had negative 2 times itself 3 times. So I'm going to do parentheses and put the negative 2 inside. I'm going to do another parentheses, put the negative 2 inside. Come outside of those parentheses and start another parentheses and then put the negative 2 inside. So Desmos will do the calculation and give you negative 8, just like we did by hand. Another thing that you can do is just go ahead and write the original expression. Put the parentheses in, put the negative 2 inside, and then what we can do is we can actually put the exponent of 3 on that base. So to put an exponent of 3, you're going to look for the button that looks like this. A to the power of, and it has a b as an exponent. When I hit that, it's going to move into the exponent position, and I'm going to type a 3. So these two things really represent exactly the same thing, and we get exactly the same final answer. All right, now these next two examples, I want you to see how similar they are and also how they're different. The first example has -2 in the parentheses raised to the power of 4. So in this example, the exponent of 4 applies to everything that's directly in front of it in the parentheses. So we're actually going to write down the -2 4 times. So we're going to write down everything in the parentheses, multiply times itself 4 times. So you notice that the number gets multiplied times itself 4 times, and then also the negative gets written down and multiplied in 4 times. Okay, what do I get when I multiply -2 times itself 4 times? So let's do the simplification. -2 times -2 gives me a +4. -2 times -2 gives me another +4. Positive times a positive gives me a +16. Okay, we can also do that in Desmos, so let's just take a peek at that. Okay, we've already written down 3 of those, so let's just do a 4th. I'm going to multiply that also by a -2, and we get that +16. Let's also do it the shortcut way. Put the parentheses, put the -2 inside, come outside of the parentheses, and I'm going to put an exponent of 4, and we see we also get a +16. So I want you to notice that those two things really are exactly the same thing and give us the same final answer. Now what about this one? How is this one different? You'll notice that the previous example had the parentheses, but this example does not have the parentheses. So what that's going to change is what we're going to write down 4 times. It's going to change the base. The base in this case is only the +2. So it's only what's directly in front of the exponent. If you don't have the parentheses, then the negative does not get written down 4 times. So the only thing that you're going to write down 4 times is the 2. Okay, what happens to that negative? Well, it gets to sit right out front, but we only write it 1 time. So it does not get written down 4 times, it only gets written down once, and it's hanging out front. Okay, so in this case, we could think about that as a -2 if we wished. -2 times +2 would give me a -4 overall. +2 times a +2 gives me a +4. And a -4 times a +4 would give us an overall final answer of -16. So I want you to notice the difference between those last two examples. What do the parentheses do, and what happens when we don't have the parentheses? We want to make sure we're careful that we see the difference between what gets written down 4 times and what does not in those two examples. Okay, let's also put this into Desmos and compare. Okay, so I'm going to come back down here, and I'm going to do just the -2, and I'm going to raise that to the power of 4. So you'll notice that Desmos gives me a -16. So your calculator is also going to recognize the difference between having the parentheses around the -2 and not having the parentheses around the -2. Alright, for these next examples, we're going to introduce variables, and we're going to work with our exponent rules using variables. So I want to simplify these 4 expressions. I have x times x times x times x. What's a better way of writing that? Well, we have the same thing multiplied times itself 4 times. So I can write this using exponents. That would be x, that's the base. How many times did I multiply it times itself? 4 times, so we can write that as its exponent. Okay, so this would be a simplified way of writing x times itself 4 times. Another way of thinking about this is when you're multiplying like bases, you can add the exponents. So if I add 1 plus 1 plus 1 plus 1, I get 4. So if I'm multiplying between the same things, I can just add the exponents on all of those things as a really easy way of multiplying something times itself a certain number of times. Okay. Now what about this example? How is this one going to be different? How is it going to be similar? So I have a negative times a negative times a negative times a negative, and I have x times x times x times x, right? Okay, what do I get when I multiply a negative x times a negative x? Well, negative times a negative is a positive, right? We'll come down here. So it's a positive x. How many times am I multiplying x times itself? Once, twice, so 2 times. So I'm going to write that as an exponent of 2. So that's a positive x squared. Now let's do the same thing over here. Negative x times negative x, that's a positive. And then I have an x multiplied times itself 2 times. So that's an x squared. So now I have a positive x squared times a positive x squared. So our final answer would be positive. How many x's overall am I multiplying together? Well, I can go up here and see that I'm multiplying 4 of those x's together. I can also see from here that I'm multiplying 2 x's times another 2 x's. I can add those exponents. 2 plus 2 gives me a final exponent of 4. So all of that simplifies to be a positive x times itself 4 times. Okay, what do I get when I do negative x times negative x times negative x? Okay, so let's do a little simplification here. A negative times a negative is a positive, and then x times itself, I can simplify that using exponents to be x squared. Okay, 2 x's multiplied together, that's the easier way of writing it. Now I'm going to multiply that times that last negative x. X squared times a negative x. Positive times a negative, my final answer is negative. How many x's am I officially multiplying together? So I have 2 x's here, I have another x here. Okay, one way is to go back up here and say, well, I had 3 x's that I was multiplying together. But we can also add the exponents here. So I have 2 and I have 1, so we're multiplying a total of 3 x's together. So this would be our simplified final answer. Okay, what about x squared times x cubed? Okay, we're going to talk about kind of 2 different ways of doing this. One shortcut way of doing that would be to say, well, if I'm multiplying like bases, so these bases are the same, and if I'm multiplying in between, then the shortcut of multiplying like bases is just to add the exponents. Keep the same base. So I'm going to write this as x. 2 plus 3 gives me a total of 5. Let's keep the same base, add the exponents. That's a shortcut way of multiplying like bases. Okay, what's the long way of doing it? So there's another way that you could do this. A long way of doing this would be to say, well, if I have x squared, what does that mean? That means to multiply x times itself twice. So I can stretch that out kind of using that long notation. I'm multiplying that times x cubed. So that's x times itself 3 times. So that's 1, 2, 3. So I can stretch out what that exponent means for both of those bases. Now, all of those are really the same x, right? So that's really x times x times x times x times x. How do I write it if I'm multiplying 5 x's together? Well, the shortcut way of writing that is x to the power of 5. So whether you use the shortcut rule for exponents or you stretch it out and you count up all your x's by doing it the long way, your final answer is going to be the same. All right, let's look at order of operations. Order of operations is an agreed upon order that we're going to do adding and subtracting, multiplying and dividing, and exponents. So you may have heard of PEMDAS. Okay, we're going to bring this up again later as well. PEMDAS says, number 1, perform operations within innermost parentheses and then work outward. That's what the P means. The P is talking about doing things inside of parentheses. Okay, so the next thing that we're going to do is the E. That's the exponents. We're going to do any exponents that we see. Okay. The M and the D are actually performed at the same time. We perform them as they occur from left to right, but that's step 3. So we have to do parentheses first, exponents next, and then any multiplication and division comes third. The very last thing that we do, the 4th order of operation, is any addition and subtraction as they appear from left to right. So we have to make sure that we do the operations in this agreed upon order. So for example, if I have 6 plus 5, parentheses, x minus 6 raised to the power of 3. I have to follow these rules of operations. So I can't do 6 plus 5. So you might be tempted to say, well, I'll just do 6 plus 5 and get 11 and then go from there. Well, adding and subtracting isn't until the very end. So the first thing I have to do is say, well, what's inside of parentheses that I can do? So inside of the parentheses here, I have 8 minus 6. So I have to do that first before I do anything else. So I'm going to copy down everything else. So I have 6 plus 5, parentheses. 8 minus 6 is a positive 2. So I'm going to leave that right inside of the parentheses. Okay, now what's the next thing that I have to do? Well, the next operation is exponents. So I have to do any exponents. So I have 6 plus 5, and the exponent that I see is right here. So I have to find out what is the base for that exponent of 3. Well, that base is the 2. So what is 2 to the power of 3? So we'll come to the side. Well, that's 2 times itself 3 times, which is 8. So I'm going to put right here the 8. Now what's happening between the 5 and that parentheses is multiplication, right? That's an implied multiplication. So when I do the exponent 2 to the power of 3 and get 8, I'm going to write that indicated multiplication that still exists between the 5 and the 8. Alright, so what's the next operation that I can perform? Well, any multiplication and division that I see from left to right. So I have a multiplication right here between the 5 and the 8. So I have to do 6 plus, and this multiplication here gives me a positive 40. 5 times 8 is 40. The very last thing that I'm allowed to perform is any addition or subtraction that I see from left to right. So what's 6 plus 40? Well, that gives me 46. Right, so order of operations, really important. It's probably one of the most important things that you can take with you to the next math class. Really important that you understand these order of operations. Right, so let's do a couple more examples. Alright, so we have negative 5 squared minus 2 times a negative 3 plus 1. So we're going to follow our order of operations PEMDAS. Okay, so the first thing I have to do is look inside parentheses and see if there's anything that I can do. So inside of this parentheses I have a 5, nothing I can do there. Inside of that parentheses I have a negative 3. So there's no operations to perform inside of the parentheses. So let's move on to the next operation. The next operation is exponents. I only have one exponent, and it's right here. What is the base for that exponent? Well, it's only what's directly in front of it in the parentheses, so it's only the 5. So if I come to the side, that would be 5 written down times itself twice. That's 25. That negative was not part of the parentheses, so it's only going to be written down once, and we're just going to copy it down to the next problem in front of the 25. Okay, so we performed our exponent correctly. And now we're going to move on to the next phase, which is multiplication and division from left to right. So do we see any multiplication or division as we move through the expression from left to right? And I do see a multiplication here between the negative 2 and the negative 3. So negative 2 times a negative 3, that's a positive 6. Alright, the last thing I'm allowed to do is any addition or subtraction, and I do that from left to right. So I'm going to perform this addition first. What is negative 25 plus 6? You can put that into decimals if you want to, but I get a negative 19. And so the next addition that I see there is that plus 1. So what's a negative 19 plus 1? I get a negative 18. So our final answer is a negative 18. Now before we go on to the next example, I want to mention again that decimals can do a lot of this stuff for you. So I'm going to go back to decimals. Okay, I'm going to make this a little bit smaller. Okay, I'm just going to get rid of what we had before. Now let's type this into decimals from the very beginning. Alright, put the negative, parentheses come afterwards, we'll put the 5. Outside of the parentheses, I'm going to square. So if I put a square, I actually can hit this button right here that will put an exponent of 2 on whatever I want. So I'm going to hit that button. It takes care of that for me. Then I'm going to type minus 2, parentheses, negative 3, come outside of the parentheses, and then put the +1. So I'm going to copy that directly into Desmos as I see it. The nice thing about Desmos is that it will do order of operations perfectly for you. Okay, so I encourage you to use Desmos. It's a good idea. Okay. Alright, so let's practice the next one by hand, and then we'll practice putting it also into Desmos. Okay, so we're going to follow PEMDAS. So anytime that we simplify an expression, we're always going to follow order of operations using PEMDAS. Alright, the first thing says check for inside of parentheses if there's anything that you can do inside of them. So -2 and -2, there's really nothing to perform inside of the parentheses. So we'll move on to the next operation, which is exponents. And we do have some exponents that we can perform. So let's do -2 to the power of 4. We can come down here and remind us what that means. That's -2 times itself 4 times. And we're going to write down the negative also 4 times because it's inside of the parentheses. Okay, so I can do this by hand. -2 times a -2 is a +4. Another +4, so I get overall a +16. Okay, now I have another exponent that I can perform. Right, so I have -2 squared. So I need to take care of that exponent as well. That's -2 times itself twice. And because the negative is also in the parentheses there in front of that exponent, I'm also going to include negative twice as well. So -2 times -2, that gives me a +4. Now in between the -7 and that parentheses was an indicated multiplication. We're still keeping that multiplication in between the -7 and what we get out of performing that exponent. Okay, we'll bring down the -8. Alright, so we've performed all of our exponents. The next phase of our operations is any multiplication and division I see from left to right. So as I move from left to right, I do see a multiplication between the -7 and the 4. -7 times a +4 is a -28. Alright, so the last thing I do is any addition and subtraction that I see from left to right. So I have a subtraction here. What is 16 minus 28? Right, that gives me -12. Then I'm going to bring down the -8 again. What's -12 minus 8? That gives me an overall value of -20. Now you're welcome at any point there to put that into Desmos. If you weren't sure about 16 minus 28, you're welcome to use a calculator. Calculator use is encouraged in this course. You can even go back to the very beginning and put that into Desmos and just get to the -20. Okay, so let's practice just doing that in Desmos. So I'm going to type in my parentheses, and inside the parentheses I'm going to type in the -2. Come outside of the parentheses, then I'm going to hit this button here to give me an exponent that I'm going to type in as a 4. Now you want to be careful here. Right now, if I keep typing, I am up in that exponent. I don't want to be up in that exponent. So I'm going to go back, and I want to hit this button right here, this arrow, that's going to bring you out of the exponent. Okay, so that gives me what I want, -7 times, I'm going to do my parentheses, put -2 inside of the parentheses. Once again, I want to come out of the parentheses. Okay, and then I'm going to hit the exponent button, and I'm going to type a 2. Okay, you can also do that by hitting the a squared button, and that'll give you the exponent of 2 as well. But I want to practice again coming out of that exponent. If I keep typing here, okay, it's going to add to that exponent. So I'm going to again hit this arrow right here that pulls me out of the exponent position and comes down to be a big regular part of the expression. Now I'm going to hit -8. And that gives us that -20 that we got when we did PEMDAS by hand. So Desmos will follow order of operations perfectly for you. I would encourage you to practice using Desmos to do these expressions. Alright, the last thing I want to review is multiplying expressions that contain variables. Okay, so I have a couple of examples here. Both of these are going to use something called distribution, or the distributive property. So here we see that we have a -5x, and that's in front of some parentheses. and the parentheses are containing two terms, a 4x and then a plus 5. Terms are things separated by plus and minus signs. So inside of here we have what we call two terms. The negative 5x by itself is one term. Okay. So if I want to multiply a one-term thing times a two-term thing that's contained inside of the parentheses, we're going to use what we call distribution. Distribution means that you are going to distribute the multiplication into the parentheses. So I'm going to multiply negative 5x times a positive 4x. So that gives me negative 20, and then x times x, we're going to write that using exponents. That's 1x here, 1x here, I get x squared. Okay, now the distribution means that you're also going to multiply negative 5x times the other term that's contained inside of the parentheses. So negative 5 times a positive 5, that gives me a negative 25, and there's only one x multiplied in, so it's just negative 25x. Okay, so that's called distribution. In the second example, we have also a one-term thing, so that's the 7x squared, times a two-term group. So what's inside of the parentheses is two terms, and so I'm going to use distribution here as well. So what is a positive 7x squared times x cubed? Now we want to keep in mind here that we have x squared and x cubed, we have like bases, and we are multiplying, so we're allowed to add the exponents. 2 plus 3 gives me a final answer of 5. So that's 7x to the power of 5. Now we're going to multiply that 7x squared times a negative 9. 7x squared times a negative 9, so I get a negative 63. And then I only have x squared in the mix. We don't have another exponent behind the 9, so that's all I get. So we get x squared. So when you're multiplying like bases, we get to add our exponents. That's a nice little shortcut that we can use going forward. Alright, something else that we want to talk about is something called the FOIL method. So we're going to use the FOIL method a bunch. So we got to get used to seeing it. Okay, what is the FOIL method used for? The FOIL method is used when you have two terms inside of parentheses, and you're going to multiply that times another two terms inside of parentheses. Okay, so two terms times two terms where they're both in parentheses. So right between the parentheses, that's right there, that's an implied multiplication. So how do we multiply two terms times two terms and they're both in parentheses? Well, we call this the FOIL method. We're going to multiply the first two terms in each group together. So we call this the first. First times the first, that's the F part of the FOIL. What's x times x? When I multiply those first two terms together, what do I get? X times x, we simplify that as x squared. Alright, now the O part of FOIL, okay, this is why we call it the FOIL method, is to multiply the two outside things together. So the things that are furthest apart. So the two terms that are furthest apart, those are the outside two terms. That's x times a positive 1. X times a positive 1 gives me a positive x. So I've got that. Okay, now call it FOIL. The next one is the I, so it's the inside. So we say the inside two terms, so that's going to be the positive 9 and that positive x. So we're going to multiply the two inside terms. Positive 9 times a positive x. That gives me a positive 9x. Okay. So the last part of FOIL is that last term, so L for last. The last two terms in each group. So that's the positive 9 and then the positive 1. Alright, so that's a positive 9 times a positive 1. So overall that gives me a positive 9. Now after we do the FOIL method, so we multiply the first two, outer two, inner two, and last two, we end up with 4 separate terms. So I have these 4 terms after I do that FOIL method. Okay, 4 terms. What do I do with these 4 terms? Well, I want to combine like terms. So remember, combining like terms, what does that mean? Can I add or subtract these is really the question. We're only allowed to add or subtract terms or combine them if they have exactly the same variable portion and exactly the same exponent on that variable portion. So x squared, there's no like terms to x squared. In order to be able to combine x squared with one of these other terms, I would have to see another x squared. Since I don't see another x squared, then x squared is just going to come on down to be part of my final answer. The next term is x. Do I see another term that has just plain old x? Think of it, if you want to, as x to the power of 1. Yes, I do. Here's another term that has a variable portion that contains just x. So what I'm allowed to do, I could think about that as a plus 1 in front if I want, but what I'm allowed to do is I'm allowed to combine these two like terms. So like terms, things that can be combined, have to have exactly the same variable portion. So the same variables and the same exponents on those variables. So what's 1x plus 9x? Well, that gives me plus 10x. Okay, so the last term that I see is a positive 9. That has no variables attached to it at all. So that is not a like term to any of the others. Okay. The only thing that this can be combined with is another term that has no variables at all. So there's nothing I can do with that, so it just comes on down to be part of my final answer. So our final answer is x squared plus 10x plus 9. So our final answer is just those three terms. So let's practice this method. Okay, so for part A, I have 3x minus 2 times 4x plus 5. Since the parentheses are touching, that's an implied multiplication. So how do I do two-term thing times another two-term thing in parentheses? Well, we're going to use FOIL. First times the first, so that gives me 12x squared. Okay, then I'm going to do outer times the outer. So the outer two terms, that's a 3x times a positive 5. That gives me a plus 15x. Okay, now the inner times the inner. So the inner two terms, the ones that are closest together, negative 2 times a positive 4x. That gives me a negative 8x. And then the L part says do the last times the last. So the last term from each group, negative 2 times a positive 5, that gives me a negative 10. The last thing we do is to see if there's any like terms that we can combine. 12x squared, that there's no other x squared, so that term just comes on down. The 15x and the minus 8x both have exactly the same matching variable portion. So 15 minus 8 gives me a positive 7, and we keep that same matching variable portion. The negative 10 doesn't have any variables, but it's the only term that has no variables, so it's just going to come down to be part of our final answer. Okay, I want you to be careful with part B. So I have included this for a very specific reason. I'm going to put some stars by that. You have to be really careful here. We have x minus 7 squared, we have the 3, we have to follow order of operations. Okay, so be careful here. One thing to be careful about is we are not allowed to multiply or distribute in the 3 here. Why is that? Well, distribution is really the same thing as multiplication. That's really what distribution is. Distribution is down here with multiplication. What do I have to do before I can do any multiplication? Well, I have to see if there's anything I can do within the parentheses. So I always have to check for that first. Now x minus 7, I cannot combine those. Those are not like terms. So it turns out there's really nothing I can do within the parentheses. So let's move on to the next operation. That's exponents. Is there some exponent in this problem that I should perform first? Yes, there is. Here's where we're going to be careful though. The exponent of 2 applies to everything that's in front of it within the parentheses. So what we're going to do is say, well, what does it mean to square that base? Let's write it out the long way. That's x minus 7 times itself twice. So x minus 7 times x minus 7. I want you to write out what that exponent means for that two-term base. Okay, that's what I want you to do. This is going to pop up again in college algebra. This is really significant. So I put 3 stars by that. So I want you to think about what does it mean to square that two-term parentheses. Okay, we're going to write it out twice. Now I have a group of 2 times a group of 2. What do? I'm going to FOIL. So we're going to write that out twice in FOIL. Okay, I'm going to hold off on the multiplication of the 3 for the moment, and we're just going to FOIL. Alright, so the 3 will still get multiplied in eventually, but for now we're going to focus on the FOILing. First times the first gives me x squared. Outer times the outer gives me a negative 7x. Inner times the inner gives me another negative 7x. Last times the last, what's a negative 7 times a negative 7? I get a positive 49. Now if you want to, you can combine like terms within the parentheses. What's negative 7x minus 7x? That gives me a negative 14x. Now I can multiply the 3 into the parentheses. Okay, so now we're down here to the multiplication and division phase, and distribution is the same thing as multiplication. So when I do this distribution, I get 3x squared. So what's a positive 3 times a negative 14x? We're going to get a negative. I believe that's a 52x. And I believe that's a 42, so that's a negative 42x. And then what's 49 times 3? I get a positive 147. So please use a calculator for that. Pull out that calculator. We are encouraged to use calculators in this course. All right. So that's what I get after I follow all of my orders of operations. Okay, so let's do 2 more examples. Okay, so I have a 2-term thing times a 2-term thing. Okay, you can follow PEMDAS here as well. Okay. If you do follow PEMDAS, the first thing you ask yourself, is there anything I can do within the parentheses? So when I look inside of that parentheses, is there anything I can do? Well, 6x minus 7, those are not like terms, so I can't do anything. X minus 2, can't do anything there either because those are also not like terms. So we considered it. Are there any exponents? No. So we'll move on to multiplication and division. So we are multiplying here, and we know that when we have a 2-term thing multiplied times another 2-term thing, that we're going to use FOIL. First times the first, 6x times x is x squared. So 6x squared. Outer times the outer, 6x times the negative 2, I get a negative 12x. Inner times the inner, negative 7 times x gives me negative 7x. Last times the last, negative 7 times the negative 2 gives me a positive 14. Combine like terms, 6x squared. The only 2 like terms I have are the negative 12x and the negative 7x. That gives me a negative 19x, and the 14 is also not a like term to anything else. So it comes down to be part of our final answer. Now once again, negative 12, negative 7, if you do not know what that is, you are welcome to pull out your calculator or use Desmos. It's better to do it in calculator, get it right, than to guess and get it wrong. So make sure that you're practicing with those calculations. Alright, so our last example here, I have negative 5, and then I have the parentheses, and then I have the square. Alright, PEMDAS. Can I multiply the negative 5 into the parentheses? Nope. Be careful. You're going to consider, can I do anything inside of the parentheses first? And the answer to that is no. Do I have any exponents? And the answer to that one is yes. So I cannot do multiplication and division, which also means that I cannot do distribution, because distribution is the same thing as multiplication. So I cannot distribute in the negative 5 until I first perform the exponents. Really important. So how do I do a binomial? A 2-term thing squared. How do I deal with that? Well, we're going to write that out twice. So x plus 8 squared is x plus 8 times itself twice. We're going to write it out twice, and then we're going to FOIL. Okay, we're going to perform that multiplication of the negative 5 last. So I'm going to FOIL here. First times the first, x squared. Outer times the outer, I get a positive 8x. Inner times the inner, I get another positive 8x. Last times the last, I get a positive 64. Combine our like terms. 8x plus 8x is a positive 16x. Okay, then I'm going to get to my next phase, and that's multiplication and division, which includes distribution. So now I can multiply in that negative 5. Negative 5 times an x squared gives me a negative 5x squared. Negative 5 times 16x, so we want to figure out what is 16 times 5. That's an 80. Negative times a positive is a negative 80, and I need to make sure I include the x. And then lastly is a negative 5 times 64. Okay, I recommend pulling out your calculator for that. That would be a negative 320. So this is our final answer. Okay, so the takeaway from today is to practice, make sure you know order of operations, make sure you know how to work with variables, make sure you know how to work with exponents, and make sure that you know how to FOIL. Okay, so those are the things that we're going to be using frequently in this course in the future.